This question number 4. Now we quickly correct it. 8, 9, 10, 11, 12, or you write 80, 90, 100, 110, and 120. So in the first one, that is already in order 5, 8, 9. The second one 0, 2, 4, 5, 9. 0, 2, 4, 5, 9. And then 0, 5. On left hand side, 8 is alone. This should be 0, 3, and then 9. Then we have 0, 6. Then we have 0, 0, 9, and 1. So this was first one is horror and then action. Action and key. We say that 8 slash 5
Yes.
is equals to 85. And on left hand side, let's say 0 slash 9 equals 90.
90.
Now what does the question say? Display this data done. What is the median length of each type of film?
So
Only middle number. There were 10 action films. So middle is of
use 5 and 6. No.
5th
5 and 6.
and 6th. So we count them.
Yes, sir.
1, 2, 3, 4, 5th, and 6th. So for horror,
It's 1.
92 plus 94 by 2, 93.
Yes, sir.
And for action, 1, 2, 3, 4, 5th, and 6th. So 5th is 100 plus 106, and middle is 103. Based on this sample, which type of film is on average longer? So we can clearly see that higher values are at the lower end of,
Action films are longer. Yes.
and also median is higher.
Yes,
The
sir.
simple answer is action.
Action films.
Action.
Now frequency polygon. We've been doing bar graphs. There's only a slight difference. Whatever values we had, suppose from 50 to 55, we had a value of 1. 55 to 60 was 6. 60 to 65, 16. 65 to 70, 12. 70 to 75, we had 4. Now the only difference is whatever class width we have, we will put a dot in center of this bar.
Yes, sir.
Then we will join all these with a straight line, pencil and ruler. So this is frequency polygon.
Yes, sir.
It is not necessary to draw the bars if you require only the frequency polygon. This diagram shows the frequency polygon for the exam results of 34 students in 2 subjects, math and French. They've used different lines for them. 2 main differences are apart. The scores obtained in math exams were significantly lower than French for most of the students. So as we can see that frequency is higher and marks is lower, between
Lower.
30.
Yes, sir.
So let's see what the questions say. Exercise 13.3b. Draw a frequency polygon for the distribution of masses of children shown in the diagram. So we'll just put a dot in between these bars
Then we match them.
and we
Yes,
will
sir.
join them with
Yes, sir.
pencil and ruler. All these points. Question
this-
number 2.
Yes.
GRS.
सर तो इसमें नीचे वाले क्वेश्चन में क्यू भी बना हुआ है तो क्यू क्या है
Q. That is second question maybe. That this is not with the first.
Second question.
In a supermarket survey, shoppers were asked 2 questions as they left. How much have you just spent? How far away do you live? The results were separated into two groups: shoppers who lived less than 2 miles from the supermarket and shoppers who lived further away. The frequency polygon shows how much shoppers in each group had spent. Decide which polygon P or Q is most likely to represent shoppers who lived less than 2 miles from the supermarket. Give your reason. What do you think?
Means, uh, uh,
One thing is for sure, P is spending less and Q is spending more. Imagine yourself in that.
P is more. Yes, sir. P is less than
P
two
is
miles from
lesser
Srinagar.
distance, P is closer. And why?
Yes, sir. Because it has less amount spent and more frequency.
It is less amount, they live near, they can visit the supermarket
Yes,
again
sir.
and again easily.
Yes, sir.
Question number 3. Scientists doing research in genetic engineering altered the genes of certain kind of rabbit. Over a period of several years, measurements were made of the adult mass of rabbit and their lifespan. The frequency polygon on the next page shows the results. What can you deduce from the two frequency polygons? Now, write one sentence about mass and one sentence about lifespan. So solid red is ordinary rabbit, adult mass, then rabbit with altered gene. They're more or less same. And on right hand side, ordinary rabbit and rabbit with altered gene. And we can see that lifespan is increasing. So what can you deduce? So write one sentence about mass. So basically mass is more or less the same. May I say average mass is same?
Yes, sir.
Sir, can't we write that we can also say the rabbit with alternative mass is a little bit high.
How do you say that again?
So I'm saying the rabbit with altered gene की जो mass है वो थोड़ी ज़्यादा है.
Yes, that is the second answer. One sentence about lifespan. So rabbit with altered gene has longer lifespan. So this was about frequency polygon. Now we are moving towards histogram. Before we start histogram, I would like to reflect back on this. The difference between bar graph and histogram. These are bars and these are histograms. What is the major difference you see?
That bar graphs are a little bit separated and the histograms are like joined together.
Very good. And I'll show you how the raw data will look like. For example, we draw from 10 less than equal to x is less than 19. 20 less than equal to x is less than 29. 30 less than equal to x is less than 39. Can you see the visible difference?
Yes.
So if we'll draw this, definitely this starts from 10 ends at 19. Then it starts from 20 and end at 29. Whatever the frequency will be, according to that, they'll have these heights. And then 30 to 39. So when the examiner will tell you to draw histogram, this is bar. So we will just come in between these two. And how will that look? See, the difference between these two is 1. So I'll move 19.5 forward and make 20.5 backwards. That is midpoint. So this
Yes,
is
sir.
x and this will become 19.5. On the other side, 19.5 x and 29.5. This is 29.5. Less than x is less than 39.5. And what should I write in place of 10?
Then, sir,
Uh,
you will write 10.5. Sorry, 9.5.
9.5, right?
9.5.
So this would look like this.
Yes, sir.
So the only major difference between bar and histogram is the
Yes,
gap.
it's a bit.
Yes, sir.
Everything else stays the same: mean, median, mode, height, frequency, and the nature of questions.
Yes, sir.
So you see this data, there's no gap between them. 0 to 20, it starts from 20, then 40, 40, 50, 50, 70, 70, 100. There's no gap. To draw histogram, the height of the bars must be adjusted by calculating frequency density. Now, the major thing, let me again get this writing space. What we wrote was all of these were of same length: 10 to 19, 20 to 29, 30 to 39. But we'll have different lengths as well. For example, we have 0 is less than equal to x is less than 10. And on the other side, 10, and this is 30. And then we have 30, and this is 40. So if I just write the frequencies, let's say this is 5, this is 10, and this is 5 again. So for example, when we draw this, I start from 0, 10, 20, 30, and 40. On the other side, let's say this is 5 and this is 10. Now from 0 to 10, it is 5. Are we good with the first bar?
Yes,
Now look, from 10 to 30, it is 10. From 10 to 30, this is 10. And when you look at the third one, it is from 30 to 40, and the height is 5. Now, this is basically a misrepresentation. How is it a misrepresentation? When you look at the frequency, this is 5, this is 5, they should look equal. And yes, they do look equal to each other. But when you look at this frequency, 10, this should be double of those, but it is appearing 4 times. So what we do when we have unequal class widths, if you see this width is of 10 units and this width is of 20 units, the last width is again 10 units. Whenever we have different class widths, what do? We draw frequency density. 0 less than equal to x is less than 10, 10 to 30, and 30 to 40. Frequency was given, which was 5, 10, and 5. Now, frequency density. Formula for frequency density is frequency divided by class width. Now, I can see frequency is 5 and class width is 10. So, 5 by 10 is 0.5. Then again, 10 by 20 is 0.5. Then again, 5 by 10 is 0.5. Any objection till now about these?
no,
No, sir.
no,
Now,
sir.
see, when we draw the histogram using these data. Now, this is just a coincidence that I'm having all 3.5s. Definitely, we'll have different values. So, this is 0.5, this would be 1, and this would be 1.5. 0, 10, 20, 30, 40, trying to make equal divisions. Now, see, the first height is of 0 to 10, and height is 0.5. So, the bar looks like this. Second height is from 10 to 30. From 10 to 30, height is 0.5. 10 to 30, height is 0.5. Last 30 to 40, height is again 0.5. Now, this is a fair comparison. When we look at the frequency, 5 and 5 are of equal size. And yes, that is so in the graph, equal area. And when we look at this 10, this is double of them. So see, it appears double. So
Yes,
whenever
sir.
we have different class widths, we will go for frequency density. Now see the first one. If I just, okay, class width is already written. So 0 to 20, this is 20, 20 to 40, 40 to 50 is 10, 50 to 70, 20, and 70 to 100 is 30. Now frequency density would be frequency divided by class width. So
Yes,
1.4,
sir.
1.2, 1.5, and zero point 0.6. So see,
Yes.
the bars are of unequal width. But drawing the frequency density gives a fair comparison. For example, just see 18 and 36. This is 36, this is 18. 18 plus 18 is 36. That should be 2 times. So whatever the last one shows, these are 9 boxes. So this second one should show 18 boxes. So that is basically double in area, double frequency and double area. So this is the correct
Yes.
representation. Question number 1. The length of 20 copper nails were measured. The results are shown in the frequency table.
That's one.
Sorry.
So the answer is one for the second one.
Okay. So frequency density is frequency over class width. I have this habit to write the class widths first. 20, 5, 5, and 10. So 5 by 5 is 1. Then
Zero
7.
point seven one.
May I try 1.4?
Uh, uh,
Um,
no. Whatever.
7 by 5, no?
Yes, seven. Oh, okay,
1.4.
705.
Then 3 by 10 is 0.3. Now the examiner has left the y-axis for us to label. So I can see the highest value is 1.4. So I'll decide my scale.
zero
So
point
that is a
four
good
five
spread.
for 0.5 million.
Okay. zero point 0.5 and that is 1.0. This is 1.5. So now the first one is 0.25, which starts from 0 and ends at 20. So 0.25 is this.
Yes, sir.
And the second one is 20 to 25 and height is 1. We make a height of 1 and 20 to 20.
सर ये इस तरह का क्वेश्चन ग्राफ पेपर पे दिया होगा आपने खुद बनाना होगा.
Most probably on graph paper. And if it is a sketch, scale would be labeled. You'll have straight lines, graduated lines, grid lines. From 25 to 30, we have 1.4. So just below 1.5, 25 to 30. And last 30 to 40 is 0.3. So a bit higher than 0.25, but lesser than 0.5. So this is our histogram for the given data. The volume of 55 containers were measured and the results were used to create this frequency table. Calculate the frequency densities and draw the histogram. So that's the same exercise. Let's quickly do it. So class width is 5, 5, 10, 10, 10, 20. Frequency density is frequency
That
divided by class width. First one,
one
1 second,
0.6,
0.6. Third,
1.2,
1.2. Fourth,
1.7,
1.7.
and 1.3,
And the last one,
and uh,
20,
0.25. 0.25.
0.25. So we know what is on x-axis and frequency density is on y-axis. Frequency density, and we'll write 0, 5, 10, and equal divisions on x-axis. Question number 3. The lengths of snakes and their frequencies are shown. Lengths of snakes and their frequencies are shown in the following histogram. There are two snakes that are between 0 and 10 centimeter long. How many snakes are between 30 and 40? Now see, there are two snakes. Let me go back. Frequency density was plotted because the classes were uneven. Frequency is the
Yes.
real count, the exact count. If I may say, use the same formula, frequency density is equals to frequency over class width. And I'm just showing you using the first block that the frequency density is 0.2 and the class width is 10. Any objection in these selected values?
No,
This is
sir.
the class width for first bar and this is the frequency density. So if
Yes,
you
sir.
multiply, you get a frequency of 2 and this is that 2. Now it says how many snakes are between 30 to 40. So when I see that bar, frequency density is equal to frequency over class width. So when I see that bar from 30 to 40, I see that the frequency density is 1. So 1 equals frequency over class width is 30 to 40, which is 10. So frequency comes out to be 10. So how many snakes? 10 snakes. Any doubt?
No.
No, sir.
Other way, which I will never promote, is going for the area, count of area. So 4 boxes represent 2 snakes. That means 2 boxes will represent 1 snake. So this is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So there are multiple ways. The best one is you use the formula and just plug in the values. B part. What is the model class? Again coming back.
Yes, sir. The
Which is
highest
the model
frequency.
class in question number 2?
17, which is 1.7.
17 is the
Uh,
frequency. So model class would be
20
20.
to 30. Yes, sir.
So whichever class has the highest frequency is the model class.
Yes, sir.
But we are not drawing frequency, we are drawing frequency density.
Yes,
And
sir.
in the previous question, you can see that we may have same frequency densities 0.5, 0.5, 0.5.
Yes, sir.
So the best gauge is either you find the frequency for all the data or you see which bar has the highest area.
Yes, sir.
So coming back to this question, model class, just observe that which bar has the highest area.
Uh, 40 to 70.
If I look at 40 to 70, we have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12 boxes.
Yes,
Look at
sir.
10 to 30.
4 boxes. Okay.
These are 24 boxes. So maximum area
Uh,
is from 10
10 to 30. Yes,
to
sir.
30.
30.
So even if you'll find the frequency, which is frequency density multiplied by class width. So frequency density can be seen, which is 0.6. Class width is from 10 to 30, which is 20. 0.6 into 20 is 12. So this is 12. This was 2. We just found out this was 10. And this is 6. I wrote these frequencies. Frequency is the area of this graph. Any doubt?
Mm.
C
No,
part
sir.
says work out an estimate of the mean length of snakes. So we do nothing. We just follow the formula and plug in those values. Mean is summation fx over summation f. Now this is frequency into x. So frequency is 2. multiply by, whenever we have widths, we use the middle value. Remember that? If I have to find
Yes.
Yes,
mean
sir.
for this, I will do 5 into 2.5 plus, dictate me the next value, 3 into, I just want to make sure you do,
5.
Yes,
3 into 7.5 RS, middle values. We will
Oh,
use middle
alright.
value.
Okay, okay.
Next one is 12 into
12 into just 1.5.
RS 15, middle value.
Oh, yes.
Ali, what
7.5.
17 into
15. Uh,
uh,
I kind of don't understand.
17 into
Mm, 13 to
mid value of these two.
10,
10.
Mid value is 25.
25, yes, sir.
5. Um,
And then 13 into
13
35.
into 35
35 plus 5 into
times plus 5 into
Yeah,
5.
30, 32.
what is the mid?
Yeah. It,
But
this is
50,
yes.
50.
50.
And then we divide it with the total frequency, which is 55. And we'll get the mean. Don't
Oh,
mess it up in exam, or remember what we have to do. Questions are easy. We just have to remember what we have to do.
sir, can you go up a little
Yes,
bit?
sir.
I want to see that again. Okay, sir. No understand.
Okay, question number 3. We were doing C part. Work out the estimate of mean. So we know mean is frequency into x plus frequency into x. So first frequency is 2, and we see this was from 0 to 10, and we use the middle number. Next frequency is 12 into middle number is 20 plus 10 into what is the middle number?
Uh, 25, 15. I mean, okay, okay. 35.
So middle number is 35 plus
6
frequency,
into 55.
middle number is 50,
55.
Times
Yes, 55.
and divided by total frequency, which is 2 plus 12 plus
2
10,
plus
6. Use your calculators and solve with me.
Yes, sir.
so the frequency will be 30 and 2 times
I'm getting 31.
Yes, sir.
Do let me know if you get a different answer.
Sir, I get the same answer.
Now, most probably
yes,
question
sir.
would start repeating itself.
Yes, next
Yes,
question.
sir.
We have to
The
talk.
table shows some results of running race. Copy and complete the histogram using the data.
We have to draw the
These
frequency
are
density.
frequency density. This is frequency density, which we have to plot. These are the class widths.
Uh,
20. What is the class width of second class?
10, 10,
10.
and
Next
then
one,
20 and then 10, 20 and 10.
10. Frequency density.
And then 32 divided by 20.
Frequency divided by class width.
Um, it will be 1.6.
Sorry, just let me do this. Now, 32 by 20 is
1.6. And
1.2,
then it's 2. And then it's 0.8.
0.8,
And then it's 1.2.
1.2. So now we know the frequency density and we know the widths. 0 to 20 is already done.
Yes,
But we should know that this is 1.6. If this is 1.6, I should know what these boxes mean. I'm counting these boxes 1, 2, 3, 4, 5, 6, 7, 8. So 1.6 divided by 8. Now I know that one box is 0 0.2.
Yes, sir.
Yes.
0.2, 0.4, 0 0.6, 7, 8, 1.0, 1.2, 1.4. Now the second one, 20 to 30 is 2. This is already 1.6,
Yes,
1.8,
sir.
and this
1.8.
is 2.0.
Okay.
So 2.0, and from 20 to 30. Third
Yes,
one,
sir.
0.8, 2, 4, 6, 8. This is 0.8 and it ends at 50. Last one, 50 to 60, which is at a height of 1.2. So this is 1.2, 50 to 60, and this. In exam, you'll do this with lead pencil and scale.
Yes,
Yes.
sir.
And you can also shade it a little for the examiner to read, make it easy for him to
Yes,
read.
sir.
Question number 5. The masses of 30 hum- Humboldt squid were measured and are shown in the table. Draw a histogram to represent this data. So we first check if the classes are equal or not. So class widths are clearly different. 10, 5, 5,
Yes,
5,
sir.
and 55 to 70 is 15. Frequency density, frequency divided by class width, 0.5, 1.4, 2, 1, and 3 by 15 is 0.2. Now we just have to draw that. Note that the masses do not start from 0. This is shown on the graph. This is also known as jack line. When the data is like large enough, you can just ignore that. Let's start from the relevant value. I'm going to the next question. I hope you now know how to draw these bars. Let's quickly draw it. 30 to 40 is 0.5. So this is 0.5. 40 to 45 is 1.4. 1.4 till 45. Then 45 to 50 is 2. 50 to 55 is 5. Is 1. And 55 to 70, 60, 65, 70 is 0.2. It would look much better on graph page and once done with pencil and ruler. Question number 6. The ages of 120 people passing through an airport security gate were recorded and are shown in the frequency table. The class boundaries are 0, 10, 15, 20, 30, and 40. Draw the histogram for the data. So exactly the same thing. Class width 10, 5, 5, 10, and 10. Frequency density, frequency divided by class width 1.8, and 46 by 5 is 9.2. 35 by 5, 7. 38 by 10 is 1.3 and 0.8. So just drawing the histogram. And then these are some practice questions. Do you know anything about scatter diagrams?
Yes, sir.
Line of best fit?
Yes. So I think so. You can just explain line of best fit one time.
I'll explain. Scatter diagram, line of best fit. I'm just looking how much is left cumulative, pie charts. Almost done. Okay. Inshallah, most probably max 2 classes, and this will be completed. Okay, scatter diagram is firstly whatever data you have, you just plot that, irrespective of anything. And this would look like this. Some value is going up, some is going down, but most probably I can see that the trend is negative. The line of best fit is not the line necessary passing through the points maximum or all, and not at all. For example, we have data looking like this. So line of best fit may be this one, passing through none of the points, but shows the average. Almost almost same points above and below the line. So if we have data like this, for example, we have some rough displayed data. So line of best fit would be this. The first one is positive, the second one is negative. When both of the values are increasing, x is also increasing and y is also increasing, then we call it positive relation. And in this, if x is increasing and y is decreasing, we call it negative relation. You can also relate it with the gradient. Positive gradient is positive relation, negative gradient is negative relation. So line of best fit, this is line of best fit, and as you can see, both are increasing, but the spread is a lot. So it he calls it weak positive, and this is negative correlation. So just go through these, make some histograms. We have only 7, 8, 9, 3 questions. Try to start from the ninth question if you have less time. So 9, 8, 7, and give some time to scatter diagram as well. If there will be any issue, we'll discuss tomorrow, and probably in 1 to 2 classes we'll be able to complete this chapter.
Yes, sir.
And